This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. Exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Hello and welcome to this special episode of the ESOcast. Leading up to ESO's 50th anniversary in October 2012, we will showcase 8 special features portraying ESO's first 50 years of exploring the southern sky. Have you ever wondered about life in the universe? Inhabited planets orbiting distant stars? Well, astronomers have for centuries. After all, with so many galaxies and each with so many stars, how could the Earth be unique? In 1995, Swiss astronomers Michel Mayor and Didier Queloz were the first to discover an exoplanet orbiting a normal star. Since then, planet hunters have found many hundreds of alien worlds, large and small, hot and cold, and in a wide variety of orbits. Now, we're on the brink of discovering Earth's twin sisters. And in the future, a planet with life. The holy grail of astrobiologists.
The European Southern Observatory plays an important role in the search for exoplanets. Michel Mayor's team found hundreds of them from Cerro Larrea, ESO's first Chilean foothold. Here's the corally spectrograph mounted on the Swiss Leonhard Euler telescope. It measures the tiny wobbles of stars caused by the gravity of orbiting planets. ESO's venerable 3.6-meter telescope is also hunting for exoplanets.
The HARP spectrograph is the most accurate in the world. So far, it's discovered more than 150 planets.
Its biggest trophy, a rich system containing at least 5 and maybe as many as 7 alien worlds.
But there are other ways to find exoplanets. In 2006, the 1.5-meter Danish telescope helped to discover a distant planet that is just 5 times more massive than the Earth.
The trick? Gravitational microlensing. The planet and its parent star passed in front of a brighter star in the background, magnifying its image. And in some cases, you can even capture exoplanets on camera. In 2004, NACO, the adaptive optics camera on the Very Large Telescope, took the first image ever of an exoplanet. The red dot in this image is a giant planet orbiting a brown dwarf star. In 2010, NACO went one step further. 130 light-years away from Earth. It is younger and brighter than the Sun, and 4 planets circle around it in wide orbits. NACO's eagle-eyed vision made it possible to measure the light of planet C, a gas giant 10 times more massive than Jupiter. Despite the glare of the parent star, the feeble light of the planet could be stretched out into a spectrum, revealing details about the atmosphere. Today, many exoplanets are discovered when they transit across their parent stars. If we happen to see the planet's orbit edge on, it will pass in front of its star every cycle. Thus, tiny regular brightness dips in the light of a star betray the existence of an orbiting planet.
The TRAPPIST telescope at Larrea will help search for these elusive transits.
Meanwhile, the Very Large Telescope has studied a transiting planet in exquisite detail. Meet GJ1214b, a super-Earth 2.6 times larger than our home planet. During transits, the planet's atmosphere partly absorbs the light of the parent star. ESO's sensitive force spectrograph revealed that GJ1214b might well be a hot and steamy sauna world. Gas giants and sauna worlds are inhospitable to life, but the hunt is not over yet. Soon, the new SPHERE instrument will be installed at the VLT. SPHERE will be able to spot faint planets in the glare of their host stars. In 2016, the Espresso spectrograph will arrive at the VLT and greatly surpass the current HARPS instrument. And ESO's extremely large telescope, once completed, may well find evidence for alien biospheres. On Earth, life is abundant. Northern Chile offers its share of condors, vicuñas, vizcachas, and giant cacti.
Even the arid soil of the Atacama Desert teems with hardy microbes.
We've found the building blocks of life in interstellar space. We've learned that planets are abundant. Billions of years ago, comets brought water and organic molecules to Earth. Wouldn't we expect the same thing to happen elsewhere? Or are we alone?
It's the biggest question ever. And the answer is almost within reach. This is Dr. J, signing off from this special episode of the ESOcast. Join me again next time for another cosmic adventure.
This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. Exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Hello and welcome to this special episode of the ESOcast. Leading up to ESO's 50th anniversary in October 2012, we will showcase 8 special features portraying ESO's first 50 years of exploring the southern sky.
Astronomy is big science. It's a vast universe out there, and the exploration of the cosmos requires huge instruments. This is the 5-meter Hale reflector on Paloma Mountain. When the European Southern Observatory came into being 50 years ago, it was the largest telescope in the world. ESO's Very Large Telescope at Cerro Paranal is the state-of-the-art now. As the most powerful observatory in history, it has revealed the full splendor of the universe in which we live. But astronomers have set their sights on even bigger instruments, and ESO is realizing their dreams. San Pedro de Atacama. Tucked amidst breathtaking scenery and natural wonders, this picturesque town is home to indigenous Atacameños and adventurous backpackers alike. And ESO astronomers and technicians.
Not far from San Pedro, ESO's first dream machine is taking shape. It's called ALMA, the Atacama Large Millimeter Submillimeter Array. ALMA is a joint project of Europe, North America and East Asia. It operates like a giant zoom lens. Close together, the 66 antennas provide a wide-angle view, but spread apart, they reveal much finer detail over a smaller area of sky. At submillimeter wavelengths, ALMA sees the universe in a different light. But what will it reveal?
The birth of the very first galaxies in the universe in the wake of the Big Bang. Cold and dusty clouds of molecular gas, the stellar nurseries where new suns and planets are born. And the chemistry of the cosmos. ALMA will track down organic molecules, the building blocks of life.
Construction of the ALMA antennas is in full swing. Two giant transporters, called Otto and Lore, take the Tachnantor Plateau. At 5,000 meters above sea level, the array provides an unprecedented view of the microwave universe. While ALMA is nearly completed, ESO's next dream machine is still a few years away. See that mountain over there? That's Cerro Amazonas. Not far from Paranal, it will be home to the largest telescope in the history of mankind. Meet the European Extremely Large Telescope, the world's biggest eye on the sky.
Sporting a mirror almost 40 meters across, the EELT simply dwarfs every telescope that preceded it. Almost 800 computer-controlled mirror segments. Complex optics to provide the sharpest possible images. A dome as tall as a church steeple. The EELT is an exercise in superlatives. But the real wonder, of course, is in the universe out there. The EELT will reveal planets orbiting other stars. Its spectrographs will sniff the atmosphere of these alien worlds, looking for biosignatures. Further away, the EELT will study individual stars in other galaxies. It's like meeting the inhabitants of neighboring cities for the first time. Working as a cosmic time machine, the giant telescope lets us look back billions of years to learn how everything began. And it may solve the riddle of the accelerating universe, the mysterious fact that galaxies are pushed away from each other faster and faster.
Astronomy is big science, and it's a science of big mysteries. Is there life beyond Earth? What's the origin of the universe? ESO's new monster telescope will help in our quest to understand. We're not there yet, but it won't take long. So what's next? Well, no one knows, but ESO is ready for the adventure. This is Dr. J, signing off from this special episode of the ESOcast. Join me again next time for another cosmic adventure.